And now we turn our attention to 7.3, and the focus is potential hydrogen, the pH. And we're going to first take a look at the impact and then its uses in the skincare products and services. And then we're going to take a look at a process called ionization, how the pH is, upon which the pH concept of pH is based. And so let's just read through this. It says Danish biochemist Søren Sørensen invented the pH scale for measuring the acidity of a substance in 1909. And what he based it on was the concept of water. So water as being, which is H2O, being the at a particular as neutral. And so considering water as neutral, you do a comparison with water, and if the water neutrality is measured at 7, and why measured at 7 is a little bit is a bit of in depth understanding of pH. It will require that, but you have a certain amount of ionization that happens in water, and that if you measure that, it's measured at 7. So if you keep 7 as a neutral, then anything that is below 7 is called an acid. Okay, and then anything above 7 is called alkaline. Okay, and I know I'm drawing it here, but we also see it right here. We see 7 as the water. It's distilled water right here. And we also see neutrality and neutral state here. And then we see various compounds, baking soda, as we move towards the alkaline, basic or base, also called basic environment. And we see a lot of the soaps, and the lye is a very strong form of soap, even ammonia, and so baking soda. All these are what we call in the alkaline category. Then acidic, and one of them being lemon juice, which we are very familiar with, some peroxide, and then vinegar. And these are what we call in the acidic environment. And then we also, it's important to note that hair and skin are at about close to 5 or 5.5. And so in this range right here, and that's our pH range. And so how acidic and how alkaline the environment is measured by pH. And so with 7 being neutral, a pH below 7 is acidic, and pH above 7 is alkaline solution. Now, what does pH stand for? pH stands for potential hydrogen. And so potential hydrogen meaning how much of the hydrogen ions are in a particular solution. And so the potential of hydrogen, meaning the hydrogen released of a substance in its relative degree of acidity or alkalinity, is measured on the scale of 0 to 14. And so we do have 0 to 14 scale, and that's the common range. While we do have some of the numbers do go into the negatives as well, so we'll have -1, -2, but not much more than that. And so in those readings, we can measure the pH scale, but generally pH scale stays within 0 to 14 as a measurement. Notice that the term pH written with a small p, a p to represent potential, or represents the quantity, and a capital H represents the hydrogen ion. So hydrogen ion is H plus, and the symbol pH represents the quantity of hydrogen ion. Understand pH and how it affects the hair, skin, nail is essential to understanding all salon and spa services. So it's important to look at that, and that we'll see how this is utilized in a as an esthetician, what you will be taking a look at when you measure pHs and the alkalinity and the acidity of substances. So acids, and then we have alkalis. So acids, what are acids? Are substances that have a pH below 7. And here's some of the properties. They taste sour, turn litmus paper from blue to red. And we have an activity, suggested activity, that we purchase a litmus paper and test it on certain products. And then this litmus paper will turn blue to red. And there are certain litmus papers that will go from red to blue as well to measure, and then they have a range, a color range that you will be able to then see, measure what your pH is of your particular solution. And you could use that to even measure your skin pH. The lower the pH number, the greater the degree of acidity. So what are we talking about there? If 7 is our neutral, then it says if the number is going lower than 7, it's acidic. On the other side, alkalis are also known as bases and have pH above 7. And their characteristics is they taste bitter. Here's sourness, and we know that lemons are always sour. But if we taste soap, that's why our mothers, if we said something wrong, made us eat soap to wash our mouth out with soap. And actually, that never happened to me, but I've heard that. And soap tastes bitter. And then it turns litmus paper from red to blue. And it depends on the kind of litmus paper you get. You can get a reddish litmus paper, you can get a bluish paper, and then measure either alkalinity or acidity. The higher the pH number, the greater the degree of alkalinity, and that's talking about this. The higher the number, the more alkaline the substance is. The pH of 7 is a neutral solution. So just reminding that our neutral spot is pH 7. Then as an esthetician, you're working with the skin, and it's important to know that the skin also has a pH. The skin is slightly acidic and is at pH 5.5. And you can read the skin chapter, and it talks about the significance of that. And it does that chapter does talk more in detail about the acid mantle. And so acid mantle is a defense mechanism against bacteria, against other substances. And so pH is very significant to the skin. And as a result, the products that we use or recommend to clients, it needs to be in care of that acid mantle. And so here's the acid mantle is a protective barrier against certain forms of bacteria and other microorganisms. We can influence our clients by selecting and using products that are developed for their skin type and condition. So when we look at the particular products, or when products are being developed by a particular company, they do take that into consideration, and we'll see that they have certain buffers that they do put in there that will help keep and maintain the acidity level at 5.5, around that. Okay. Now there is in the book, it says, did you know? It is important to have products contain the proper pH for a given skin type. For example, if a client, here's a recommendation, here's a suggestion. It says, for example, if a client has dry, hydrated skin, giving that client a product that is too acidic would further dry and irritate the skin. So what acids will do, and we'll put acid here, acids will start to eat things. Why? How do they break down things? They'll break down skin or any kind of biological material. Why do they break it down? Because acids are interjecting electrons into the environment, and those electrons, when the skin gets enticed, or when the biological material gets enticed to say, hey, have some electrons, eat some electrons, and then it gets enticed and starts to move towards the electrons. And if there's a very strong acid, that whole skin structure will start to either break down, and that's where you get further drying and irritation of the skin. On the other side, conversely, if a client has an oily skin type, a product that is slightly alkaline may contribute to oil and sebum buildup and possibly create acne, and the client may need a more acidic pH to their product. So you may need to move them towards more acid. But what happens with alkaline, in this case, we'll take a look at it. Hydroxide is is a good anything kind of a, let's say, sodium hydroxide is a example of a alkaline product. And what it does is, you see the oxygen in there. It loves to take electrons. Here, acids will give electrons. Alkaline products love to take, or you can almost say steal electrons. And so when you're depriving skin or depriving biological material of electrons, you're breaking down their system as well. So both aspects are breaking down. But here, what are you also causing problem for is the acid mantle. Acid mantle needs to be at 5.5. You've suddenly given them an alkaline product, and the pH changes from 5.5 to maybe even 6.5. And when it starts to do that, what happens is the sebaceous gland saying, hey, I need to bring down my acid mantle. I need to adjust it. And so you get more sebum pouring out. You get sebaceous glands that are opening up. And not only are they opening up to excrete sebum, which is the oil substance, but then they become open to bacterial infection as well. Bacteria that is sitting on the surface of the skin because you did change some pH. And the bacteria that a little bit is there, it'll seep into the sebaceous gland, and this is a gland where the hair is there. It'll go in there and cause a lot of infection. So you get acne as a result. So understanding these dynamics helps, and chemistry definitely contributes to that understanding. Then we look at pH in skincare products, and here we are going to now start analyzing our products for that purpose. When skin is exposed to extremes in pH levels, as we just saw, that dryness, dehydration, inflammation, and even bacteria can grow if the product is incorrect for a given skin type. It is important to give a client with an oily skin type a product that will help reduce oil and bacteria, rather than have them use the same product as their friend who may have a very dry skin, for instance. So if something worked for one person, you have to be careful that it's not going to just work for somebody else. You need to understand the foundation of why that particular product with that particular pH will then work for another person, and if that's the right product, because in that product line made by that particular company, they may have a better suited product that is going to be more better healing or better properties that are more what the client actually needs. So this, what is saying is, if somebody's using it and they said, hey, it worked for me, doesn't mean it's going to work for everybody. need to understand the chemical impacts, and pH is definitely a source of that understanding. The pH will be slightly different in the two products. It is important to note that while many estheticians cross over in product line using a cleanser from one line and a serum from another, it may not be beneficial to the skin as pH values can differ from line to line and might have different delivery systems within the ingredients. So two aspects are brought in. First of all, you have a continuity of pH. In other words, if you're using something in series, so you have one, two, or let's just say A, B, C. So if you're using something in series, those series may be designed to maintain a certain pH. One thing says, hey, when you use the next, it'll maintain a certain pH. This might elevate the pH a little bit. This will then bring it down. And we'll have certain buffers that will maintain the pH. But if you're mixing products then from different vendors, then what may happen is that adjustment of pH may not be there. And so that's why it's important to stay consistent in line and understand how that is impacting the pH. Second thing it's talking about is the delivery systems. And the delivery system is when you have one product may open the pores of the skin. So if this is the skin, you have open pores, or you have, and so product is seeping in, and there's a particular delivery system. So once this opens up your next product, so let's say product A opens up pores and creates that environment for seeping in. When B comes in, it will then also protect it by allowing the product to go in, and then product C may then close it up. But if that somehow you don't use this series, then that delivery system within the ingredients may not work out properly. Additionally, it is important to layer products, and that's what this is talking about, from the lowest viscosity to the highest. For example, the following products would be applied in this order: a light serum first, or ampule, then a lotion, then a cream. Products that are heavier, such as creams, if you apply cream first, may have larger molecules. So and so what may happen is, again, we are talking about this process, so of opening, delivering, and then closing or covering up. But if you somehow just cover it up first, then your second things that you apply may not work out properly, and then also may cause variation in the pH values and could potentially block a product from penetrating into the skin, and therefore should just read this carefully and analyze how. Take an example of a product and it's how it's supposed to be applied in a particular series. So as an esthetician, you're called to do that. Then another did you know is here in the book, and it talks about the pH scale is a logarithmic scale. It tells you that pH, being careful with pH and maintaining pH is very, very significant. The pH scale is a logarithmic scale. I want to explain something to you. This is a linear scale. And so as things move forward, then things consistently will, you'll see that if you bring greater amount or greater pH value here, then the strength will be equally on a linear scale. But a logarithmic scale, if you add a little bit extra, look at the strength. Strength goes from here, suddenly starts to increase and increases rapidly up. This is just an example. This is not something that's in the book, but it just gives you a visual understanding of difference between a linear and a logarithmic scale. And so what this is warning us about, this means that the pH scale A change of one whole number represents a tenfold change. So you move up here, you're actually shifting this 10 times more. And again, this is not the right type of graph here. This has nothing to do with pH, but I just wanted to bring this graph here to kind of give a visual understanding of a linear graph versus a logarithmic. And a logarithmic, what it's saying is the pH scale is measured on the logarithmic scale. If one whole number, so let's say if we go from 5, let's say 5.5 of our acid mental pH, and we shift it to suddenly say 6.1, 6.5, what we are doing is doing a tenfold, moving it up, alkaline direction, tenfold. And then same way, and they give an example of pH of 8 is 10 times more than 7. So if we go from 7 to 8, then it's 10 folds. And I gave an example of 5.5 to 6.5 because it's related to our acid mantle. And so we need to be careful of how we function with a pH. That's quite a lot. And look at this further warning that a change of 2 whole numbers indicates a change of 10 times 10 or 100-fold change. So let's again stay with our acid mantle and say if our acid mantle went from not only 6.5 but then moved it to very close to the water, which is 7.5, and we have shifted this 100-fold towards alkaline environment. So it's important to understand how the pH is measured. So and then the book also gives an example. A pH of 9 is 100 times more than a pH of 7. So a 7, 8, and then if it goes to 9, we have another tenfold here. So that results in 100-fold change. All right, and so that's another thing. And it further talks about it, even at levels that are not nearly as severe, extreme variations in pH can damage the skin's barrier function, and that's the acid mantle. This is, and so skin's barrier function, and that is the acid mantle, and can cause irritation. Buffering agents, as a result, are frequently added to skin care products. And so what are buffering agents? Buffering agents, what they do is, if we go back, it's still there. If we start to shift from, let me just actually get rid of this. If we go from 5.5 to, let's say our skin starts to, for some reason, shift towards a 6.0, then what buffering agent will do is bring it back into the 5.5, and based on how that buffering system is, and that same buffer, let's say if we're at 5 and it starts to shift more towards let's say 4.5, let's say something drastic is happening, then the same buffer, it does not need to change. It will then adjust itself back to 5.5. And that is why those buffers in the products, that's what buffers do. They watch out. They look for, hey, what's happening to that pH, and we'll bring it in our body, in our system. The term is called homeostasis, keeping a certain level of either temperature or pH. Management is very important, and buffering agents work amazing in that manner. So it brings the pH to the correct level to produce the desired effect while keeping the product safe and non-irritating to the skin. So that's the basic concept in that. But again, we do need to not ignore the concept of pH just because we think buffering the agents are going to do all the work. That may not be the case. This is why it is important for estheticians to understand the chemistry of products and to make selections based on the skin type. Skin analysis is huge. It's very significant in the conditions and the treatment processes here. The activity, that was something we did reference earlier. It's recommending, and it's in the book as well, that you can go to these scientific online purchasing places, and they do sell a litmus paper. Here's an example of the litmus paper. This is red litmus paper, and it's also called a pH testing paper. You can purchase that. It's very easy. I think this one was about $2 or $3, something like that. And so you can buy this, and then it has the paper that you can apply to a solution or your skin, and then measure it against these. So you see the pH of 11, pH of 12, and pH of 4, pH of 5, and so it is doing that measurement. So that's something that you can look into. All right, and then water and the pH. The concept here is that without going too much detail, the way the pH was measured is through the use of water as the fundamental neutral product, and that becomes your reference. But even water, while it's H2O, and we have an oxygen with two hydrogens attached to it, what they realize is that even that is not always stable. What happens is you do have a little bit of breaking in that. You get a hydrogen, and that has a positive sign, a positive charge on it, and then OH has a negative charge on it. So they separate out, and they get a variety of charges on it. So understanding pH requires that we learn the term ion, and what these are called are ions, and this process is called ionization. So an ion is an atom or molecule that carries a electrical charge. Ionization causes the atom or molecule to split into two, creating a pair of ions with opposite electrical charges. And so what are the two electrical charges? There's a negative electrical charge and there's a positive electrical charge. Negative electrical charge is called anion, and the positive charge is called cation. And that's the only way I can remember that, is because I always think about a cat's eye. So cat eye on, and so I think about a cat eye, and I always draw a cat eye like this. So thinking about a cat, if I draw, I'm sorry, let's see, how to draw a cat. And then I draw the eyes, and I always put positive in there. Say that's a cat ion, so it's a positive charge. And then I think about a lady named Anne, and she has eyes, but she's sleeping. And so I was thinking about a negative charge. So another way to draw that is we have Anne here, and her eyes are closed, and she's just enjoying her sleep there. So that's a way of remembering difference between negative as anion or cation. Okay, and here's an example of that. And so in this example, what we see is the water molecule, and it's gone through an ionization process, and what we see is cation, which is hydrogen ion with a positive charge, cation, and then a hydroxide ion, anion. And so that's the process of ionization. So just at this point, without going too much into detail, and we'll review it again, but ionization results in a cation and a anion. And cation is a positively charged electrical charge, and a and an anion is a negatively charged electric charged particle as well. A particle meaning a portion of the molecule that it splits into. And it plays a big role in even in electricity and some of the instruments that we use ionophoresis and ionization processes, and that's a great instrument and great understanding of how that works. So just a lot of knowledge there. We'll draw this topic to a conclusion at this point, and we'll pick up at 7.4 next time.